Alright, so for our final part, we're going to be dealing with quadratic inequalities. Now, whenever we're doing quadratic inequalities, what I want you to think is the wave. Now, hopefully that rings some bells here because that's the stuff that you learn from Algebra 2. So, there are some rules that you need to be aware of when it comes to the wave. So let's start off with number 12 here. We have x squared plus 4x minus 5, which is less than or equal to 0. Now, the first thing that I want you to do is determine the leading coefficient. So the leading coefficient would be the number that's in front of the term with the largest degree. So the term with the largest degree would be x squared. So what is the number in front of x squared? Well, if I don't see a number, you always assume that there is a 1. Now, that number is a positive 1, and that's what I'm going to write for the leading coefficient. That's positive 1. So that means when I do my wave, I am going to start up on the right. I'm going to be starting up on the right. Now, what I need to do is figure out the degree. The degree is basically the largest exponent that you see, which is 2. Okay, let me use a different color here. 2. And 2 is an even number, so I'm going to write even. And what's going to happen is if it's even, it's going to face the same direction as whatever I drew for the leading coefficient, right? So here, that's top right, upright, if you will. If I were to talk about the other half, right, would it be going down? Or would it be going up or top left? Well, it's even, right? So it's going to be facing the same direction. It's going to go up. So your end behavior should look like that. Okay? So, here we go. What we're going to do is we're going to look at this thing right here, and we're going to factor. So I'm going to do the x method. I'm going to have negative 5 up top, and then positive 4 down below, and the two numbers are 5 and negative 1. So I have x plus 5 times x minus 1, which is less than or equal to 0. Now, you need to set both of these quantities equal to 0. So I'll do that on the side. So x plus 5 is equal to 0. You're going to get negative 5 for your first 0, or critical point, if you will. And then I have x minus 1 equals 0, so you get x equals 1. So these two things are your critical points. Okay? And one thing that I'm going to do here is note if they are single roots or double roots. So since x is equal to negative 5 only appears once, that's a single root. So that's a single root, and what's going to happen is that we're going to cross. So we are going to cross. For x equals 1, we only have x equal 1 once. That's a single root. So we're definitely going to cross, okay? If I have x equals 1 again, then we have x equals 1 and x equals 1. That's a double root, therefore we bounce, okay? So, here's what we're going to do. We know that negative 5 appears first on the number line before 1. This is a less than or equal to. So both of these things are going to have a closed dot. Now with the wave rules, we always start on the right. But do I go top or bottom? Well, the leading coefficient says I'm going to be going top first on the right. So this is what I need to draw. Okay, now here's what I'm going to do. I'm going to approach 1, and you have to remember is one a single root or a double root? If it's a single root, we cross. If it's a double root, we bounce. Well, 1 is a single root, so we are going to cross the x-axis. So yes, this thing here is the x-axis. And then now I'm going to approach -5. That's a single root. And we are going to cross just like that. Now we're not done. We have to figure out where to shade. So since this is a less than or equal to, we're going to shade below the x-axis. And we're going to shade between the x-axis and the actual line or function. So would I be shading here? No, because there is no function involved. It's just the x-axis. Would I be shading here, like this? Well, it is between the x-axis and the function, but remember the rule is we're shading below. So this would be above, this would be above. So I would not be shading there. I would be shading right here. Remember, I would be shading between the x-axis and the actual function. Okay? So that's basically it, but I need to write my interval notation. It is going to start from -5 to +1. Square bracket, square bracket. Okay? Just like that. Okay. Let's take a look at 13. So, leading coefficient is +1 based on what we see here. The degree is 2. Since it's +1, we're going to be starting top right. Since 2, or our degree is 2, that's an even number. So if it's top right, then this is going to be top left. So our end behavior should look something like this. Okay? Now, we're going to factor this out. I have -6 up top and -1 down below. Two numbers are -3 and +2. Okay, so I'll take x minus 3 and set it equal to 0. If I add both sides by 3, you get 3. If I take this, x plus 2, set it equal to 0. If I subtract both sides by 2, I get -2. Okay, 3 appears only once, so that's a single root. -2 appears once, that's a single root, so we don't bounce at all. Now remember, this is a less than symbol, so it should be an open dot. And we are going to shade below. So here on our number line, I got -2 and then +3. Both of these are open dots. And since the leading coefficient is positive, we're going to start top right. And then I'm going to approach 3. That's a single root. We cross. And then now I'm going to approach -2. We do cross since it is a single root. So there you have it. Let's go ahead and shade. You will be shading right here. Okay? So that would be -2 to +3. Both of these get a regular looking parentheses. Okay. Number 14. We have -x squared minus 2x, which is greater than or equal to -8. Now, when we do the wave, the other side must be 0, no matter what. So I'm going to go ahead and add both sides by 8. I have -x squared minus 2x plus 8, which is greater than or equal to 0. All right. So just real quickly, you need to factor this out. Then there's a negative in front of the x squared, and I'm going to make note of that negative because that's crucial when we determine the end behavior of this polynomial inequality. But I'm going to factor the negative out. I have x squared plus 2x minus 8, which is greater than or equal to 0. Okay, and this is where I can go ahead and apply the x method. But before I do that, let's go ahead and make some notes. So the leading coefficient is, well, if we look right here, that's -1. So we're actually going to start bottom right. Okay, we're going to start bottom right. And then this thing is even. Our degree is 2. That's even. So we're going to be facing the same direction. We're going to go bottom left, right? So both of these are facing down. So our end behavior should look like this. Now, this thing, I'm going to go ahead and factor. I have -8 and +2. So I'm thinking 4 and -2. 4 times -2 is -8, and then if you add those two numbers together, you get 2. So you have a negative, and now I'm going to rewrite. I get x plus 4 times x minus 2, which is greater than or equal to 0. Now we have x plus 4 equals 0, and you get -4. And you have x minus 2 equal to 0. You get -2. So those are your critical points. Both of these are going to be single roots. So we start at -4, -4, -2. And then let's see, the sign is greater than or equal to, so both of these should be closed dots. Where do we start? Do we start top or bottom? Well, we're going to start bottom because our leading coefficient is negative, right? So here we go. Both of these are single roots, so our graph should behave this way. And it's greater than or equal to, I'm going to be shading above the graph. So remember, I needed to shade between the x-axis and the actual function. So this is the actual function, and this is the x-axis. So above would look like this. So -4, -2, both should have a square bracket. Okay. Number 15. Now I have 9 minus x squared, which is less than 0. I am just going to real quickly rewrite this as -x squared plus 9 is less than 0. That's what I'm going to look at. Okay? So here, because there's a negative, I'm going to factor this out, right? There's a negative up front. I'm going to factor the negative out. I got x squared minus 9, which is less than 0. Both of these terms are perfect squares separated by a minus sign. So I can rewrite this as negative times x plus 3 times x minus 3. Right? So if I take the square root of x squared, you get x, and you take the square root of 9, you get 3. So one should be plus, and the other should be a minus. And then this is all less than 0. Okay, so the leading coefficient is actually negative, right? So -1. There's a -1 right there. The degree is even. So if I have a leading coefficient that's negative, we're going to start bottom right. And then since the degree is even, then whatever this is, it needs to mirror. So the end behavior should look like that. Okay, and then here we have x plus 3 and x minus 3. So x plus 3 equals 0, -3, x minus 3 equals 0, +3. And both of these are single roots. So -3 and 3, open dot, open dot. I'm starting from the bottom, and then I'm crossing each time. So your answer is -3. Oops, what am I doing? I'm going ahead. Let's see. It's a less than symbol, right? So I need a shade below. So that would be here and there. So I'm going from -infinity to -3. Union, right? There's a blank space here, so you're going to write union. And then what's going on over here? So from 3 to +infinity, just like that. Okay, let's take a look at this thing right here. Leading coefficient is +1. So top right, the degree is even, so it should face the same direction. And then I'm going to factor. You get x minus 3 times x minus 3, which is greater than 0. So x minus 3 equal to 0, x is equal to 3. And then x minus 3 again equal to 0, so x equals 3. Now notice that we have x equals 3 twice, so that's a double root, and that's going to bounce. So what do? Our critical point is 3. It is an open dot. We are going to start top right. So as I approach 3, it is going to bounce just like that. It is not going to cross the x-axis whatsoever. Okay, so let's see that again. So here's 3. It's an open dot. It should look like that. It is not going to cross the x-axis. All right, so greater than, right? So I would be shading here and also there. So I'll go from -infinity to 3, union 3 to +infinity. All right, last problem for today. Here we go. So the leading coefficient is 1, +1, so it'll be facing top right. The degree is 3 this time, and that's an odd number, so what's going to happen here is it's the opposite of what this is facing. So since I face up initially, then what I'm going to do, since I have an odd degree, I'm going to face the opposite direction, which is basically facing down. So your end behavior should look like this. All right, so let's take a look at our polynomial. Remember, we have x cubed plus 3x squared minus 28x. Now remember, it's always best to factor until you no longer can. I can't use the x method for this one because all of these terms have an x, and notice that our degree is 3. What I'm going to do is I'm going to factor an x out. That's basically finding the greatest common factor. So in this case, the greatest common factor is x. So x times x squared plus 3x minus 28 is less than 0. Now this is where I can go ahead and use the x method to factor that out. If I did, I would get 7 and -4. So I have x times x plus 7 times x minus 4, which is less than 0. Now, use the degree to figure out how many critical points you should have. Since you have a degree of 3, then you should have 3 critical points. So I'm going to first set x plus 7 equal to 0, which you get -7. The second part, or the second thing that you're going to set equal to 0, is x minus 4 equal to 0. and you're going to get 4 for your second point. But remember, we should have 3 and we only have 2. What's the third one? This x. That x should be equal to 0, and I don't need to solve anything from here because x is already by itself and it's equal to a number. These should be your critical points. Now, what we're going to do is we're going to put all those critical points in order on our number line. -7 goes first because, well, that's the only negative number involved here, right? So negatives should be first and then positives. -7, then 0, and then 4. We have a less than symbol, so that means all of these critical points should have an open dot. We're going to start on the top right, and then we're going to go ahead and proceed with the wave. So looking at 4, that's a single root. So I am going to cross. And then here I'm going to approach 0. That's a single root. So I'm going to go ahead and cross. And now I'm going to approach -7. And yes, that is a single root. I am going to cross. And look at the end behavior of this thing. That matches with what we had initially. Now, the next thing that we're going to do is we're going to shade. Since we have a less than symbol, we're going to be shading below the x-axis. We would be shading right here, right there, and is that it? Yep, that's basically it. So let's figure out the interval notation. We're going to start from -infinity all the way to -7, union 0 and 4. Both of these numbers should get a regular parentheses. And that's basically the wave.